Assalamu alaikum. In this video, we are going to talk about Chapter 12 Electromagnetic Oscillations. At the end of this chapter, the student should be able to explain and interpret the free electromagnetic oscillations, analyze the free undamped electromagnetic oscillations in the series LC circuit, analyze the free damped electromagnetic oscillations in the series RLC circuit, and analyze the RLC series circuit under square voltage. In this video, we will explain and interpret the free electromagnetic oscillations. First, let's look back at the mechanical oscillations. In the case of free mechanical oscillations where friction equal to 0, the differential equation is of the form xw' plus omega 0 square x equals 0, and the solution is of the form x equal x maximum sine omega 0 t plus phi, so x of t was sinusoidal. And when friction exists in the case of free damped oscillations, the differential equation was of the form xw' plus h over mx prime plus omega square x equals 0, and the solution of this form. Now, in the case of electromagnetic oscillations, two main elements are required: a capacitor and a coil. Both elements are store and release energy. Let's say first the capacitor was initially charged. When the capacitor is connected now to the coil, we will observe a certain kind of oscillations between the capacitor and the coil, and that the voltage and the current will have a sinusoidal form. This phenomenon can be explained as follows. At t equals 0, the capacitor was initially charged, and the electric energy stored in the capacitor was maximum, while the magnetic energy stored in the coil was 0, and so the current. Now, as time increases from t equals 0 to t equal quarter period, current is going to flow from the positive plate of the capacitor in a direction taken as positive sense, so I is positive. Now the capacitor is discharging, and so it is losing energy, and at the same time the coil is gaining energy. At the end of the first quarter, the magnetic energy in the coil is maximum and the electric energy in the capacitor is 0. We can say that electric energy is transformed into magnetic energy, and the current will be maximum. Now, during the second part, the current will decrease and the coil is releasing energy. The capacitor is now absorbing that energy and being charged again. So the magnetic energy now is transforming into electrical energy. And right now, the polarity of the capacitor has been reversed because current was flowing into B terminal. At instant t equal half period, the capacitor is charged again and its charge becomes minus Q. Now in the third quarter, the capacitor will again discharge through the coil and the current is going to flow from positive terminal of the capacitor, so it will be negative since it is directed now in a direction opposite to that of the positive sense. The electric energy is transformed into magnetic energy, and at the instant t equal 3/4 of the period, the current now will be equal to minus I maximum and the magnetic energy stored in the coil will be maximum. In the fourth quarter, again the coil supplies energy to the capacitor, so the magnetic energy stored in the coil decreases, and at the instant t equal period, the capacitor now is charged and its charge becomes plus Q maximum, and the total electric energy is again equal to half Q maximum squared over C. Now the current will be again 0 and the magnetic energy stored in the coil is 0. As we see, in the first quarter, UC decreases and the current increases, so electric energy is transformed into magnetic energy. In the second quarter, the polarities of the capacitor were reversed, so UC will be negative and the current decreases since the coil loses magnetic energy. In the third quarter, current will be negative since it is directed opposite to the positive sense and the electric energy is again transforming to magnetic energy. And at the end of the fourth quarter, the energy in the circuit will be purely electric again. Note that at any instant, the electromagnetic energy is the sum of the electric and magnetic energy. In the absence of any resistance, we observe that electromagnetic energy always constant since there is no loss of energy. While if the resistance exists in the circuit, we will observe that the amplitudes of the current and the voltage UC decreases with time, so the electromagnetic energy decreasing too. Now, the free electromagnetic oscillation can be free undamped in the case of no resistance, the amplitudes of UC and the current is constant, or it could be free damped electromagnetic oscillations in the case of existence of a resistor in the circuit and the amplitudes of UC and the current decreases. Let's solve now application 1. In the following circuit, a capacitor of capacitance C equal 2 microfarad, a purely inductive coil of inductance L equal 5 millihenry, the variation of the voltage UC is represented in the opposite figure. At t equal 0 second, UC equal 2 volt and I equal 0 ampere. Now, calculate the maximum electric energy stored in the capacitor. At t equals 0, UC equal UC maximum equal 2 volt, so energy electric maximum equal to half C UC maximum squared equal to half 2 times 10 power minus 6 times 2 squared, which is equal to 4 times 10 to the power minus 6 joules. Part 2, specify the type of the electromagnetic oscillation that takes place in the LC circuit by two different methods. First method, in the absence of any resistance in the LC circuit, the type of electromagnetic oscillation is free, undamped electromagnetic oscillation. Second method, from the graph we have UC maximum is constant, it is equal to 2 volt, so the type of oscillation is free, undamped electromagnetic oscillation. Part 3, based on the type of electromagnetic oscillations obtained, calculate the value of the maximum intensity of the current traversed in the circuit. In the case of undamped free electromagnetic oscillation, the maximum value of the magnetic energy will be equal to the maximum value of the electric energy. So half Li maximum square equal to half C UC maximum square. Substituting the values of L, C and UC maximum, we will have I maximum equal to 0.04 ampere or 40 milliampere. Part 4, represent between 0 and 2 period the variation of the intensity of the electric current. Since I equal minus dq over dt equal minus c duc over dt, between t equals 0 and quarter period, UC decreases, so duc over dt is negative, so I is positive. At t equal quarter period exactly, UC equals 0, so I equal plus I maximum. And the figure of I obtained as follows. As a summary, charge oscillations between the coil and the capacitor and consequently current oscillations. These oscillations are called free electromagnetic oscillations. The electromagnetic energy stored in a circuit LC in the absence of resistance is W electromagnetic equal electric energy plus magnetic energy equal half Q squared over C plus half Li squared, which is equal to half Q maximum squared over C or half Li maximum squared. It is a constant value since there is no resistance or there is no loss of energy. The electromagnetic energy stored in the circuit RLC in the existence of resistance R, it is equal to half Q square over C plus half Li square, but it is not constant. This is the end of part 1. Thank you for your listening.